What's up, everyone? This is Ankit from EcoSikho, and we are back with another video on Math AI IB syllabus. And this video number 5 is going to be about quadratic functions. And in this video, we are going to talk about optimization with quadratic. We are going to look at quadratic inequalities, and we are going to look at sign diagram. So all of these three topics are very important from our exams point of view. So let's get started. So let's start with optimization. Let us start with optimization. So we know for a fact that whenever we are given a quadratic equation of the form y is equals to ax square plus bx plus c, the vertex will have a x coordinate. The vertex will have a x coordinate of minus b by 2. Now it depends. If the value of a is more than 0, then we get a parabola which is concave upwards. And if the value of a is less than 0, then we get a parabola which is concave downwards. So what does optimization means in this context? Optimization means the maximum or the minimum value of a quadratic function is called as the entire process is called as optimization. Was about optimization. So for a curve that is concave upwards, clearly the x coordinate lies somewhere around here. The vertex will have a x coordinate somewhere around here, and this value gives you the minimum. So the minimum value of y that occurs is at a point where x is equals to minus b by 2a. So if you want to find out the minimum value of this quadratic function, all you need to do is to plug in the value of x is equals to minus b by 2a in the original equation, and then you should be getting the value for y. And similarly, for a function that is concave downwards, if we want to find out the maximum value, mind closely, because over here this function will attain the maximum value of y at this point, and all the values are less than this point. So for a concave downwards, we get a maximum. So the maximum value of y occurs when you plug in the value of x is equals to minus b by 2a. So that was about optimization. So with this knowledge, let us do a question. And the question is, I have been given a function that looks like y is equals to 3 plus 3x minus 2x square. So from here, I should be clear that the value of a is minus 2, the value of b is 3, and the value of c is 3. And clearly, I can see that the value of a is less than 0. So I will conclude that whatever I am getting, it will be a concave downward. The parabola will be concave downward. So this curve, this parabola will attain a maximum value when we plug in the value of x is equals to minus b upon 2a. That gives me x is equals to minus b can be written as minus 3 upon 2 times minus 2. That gives me minus 3 by minus 4 or 3 by 4. And let me find out the maximum value that this function can attain. The max, whenever we talk about the maximum or the minimum value, we are interested in the value of y. So let me plug in the value of x so that I can get a y. So y is equals to 3 plus 3 times 3 by 4 minus 2 times 3 by 4 whole raised to the power 2. So after solving it, I should be getting a value of y as 4 1 by 8 or 4.125 if I'm not mathematically wrong over here. So that was your optimization. Now next, let's move on and talk about quadratic inequalities. What exactly is a quadratic inequality? So far we have been looking at equations that look like ax square plus bx plus c is equals to 0, or in some cases it used to be y. But if I have to define something in the form of ax square plus bx plus c is greater than equals to 0, then we call it a quadratic inequality. So I hope you spot the difference, because in quadratic equalities, we used to have an equal sign, but in quadratic inequalities, there is no equal sign. Rather, there is an inequality sign. So it can take a form of ax square plus bx plus c is greater than 0, or it can take a form of ax square plus bx plus c is less than equals to 0, and finally ax square plus bx plus c is less than equals to 0. So all these four are quadratic inequalities. So moving on and building up the concept of quadratic inequalities, we have a sign diagram. So let me explain it to you. What is a sign diagram with the help of a simple example? So let's say I have been given this three graphs and I need to prepare a sign diagram for these graphs. So let me do it for the panel number one. So in the panel number one, whenever we try it and whenever we go on to draw a sign diagram, we will draw a horizontal line. This horizontal line represents x-axis, and the graph clearly I can see that it cuts the x-axis at a point of -2 and 1. So I will make a -2 and I will make a 1 over here. I can see that the value of y is positive when we are less than -2. So I will write a positive sign here. The value of y is negative when we are between -2 and 1. So I will write a negative sign here. And finally, the value of the value of y is again positive when we are more than 1. Let me remove it. When we are more than 1. So I will add a positive sign here. So that's how we make a sign diagram. So a sign diagram is basically a number line which indicates the value of x for which a given function can be negative or zero or positive and finally undefined. Let me make the sign diagram for the second diagram. So I have my x-axis over here. X-axis can take any value between -infinity and +infinity. Do I need to make any cutoffs here? No, there is no cutoff required. Why? Because this is a positive definite parabola, which means that it does not intersect the x-axis, which also means that if you try to find out the value of determinant over here, it will turn out to be negative, and hence it does not cut the x-axis. So clearly I can see that whatever value of x I take, the value of y will always be positive. So I can simply add a plus sign over the entire horizontal line. And for the third one, let me make a horizontal line which stretches from -infinity to +infinity. I can clearly see that it cuts the x-axis at a value of 1. So I will plot a 1 over here. And I can also see that when the value of x is less than 1, it takes a negative value. And when the value of x is more than 1, it still takes a negative value. So I can simply add minus and minus sign onto the both sides. So that was about the sign diagram. I hope. So let's talk about two general observations. So if I have an equation of y is equals to x square, the parabola looks something like this. And if I have an equation of y is equals to x cube, the parabola looks, there is no parabola here, sorry. The graph will look something like this. Before jumping into any conclusions, let's try to make a sign diagram. So clearly in the horizontal x-axis, we have a cutoff of 0. We can see that before 0, when the value of x was negative, the function takes a positive value. And after the 0, the function still takes a positive value. And what about the second one? The second one, we can clearly see that the cutoff is again 0. And before the value when the value of x was less than 0, the parabola, not parabola, but the graph was taking a negative value. And when the value of x is positive, the graph is now taking a positive value. So what we can observe here is that whenever we are dealing with something that has a order, that has an odd power, there is a change of sign about 0. And whenever we are dealing with something that has an even power, there is no sign change about 0. So that was one observation that we could have drawn here. Moving on, let's do two more questions. So we have a question number 1 that gives me, I have to draw a sign diagram for x squared plus 2x minus 3 without using any calculator. So let's try to figure this one out. So x squared plus 2x minus 3 can be written in the form of x plus 3 into x minus 1. Okay. So if you are getting confused, you should always keep in mind that whenever we are not given a second side of the equation, that is, we are not given here that x square plus 2x minus 3 is equals to 0 or is equals to 5, we will always assume that it is equals to 0. So this thing is equals to 0. So from here, I can draw a conclusion that if I take the entire x minus 1 to the right hand side, then I will be left with x plus 3 is equals to 0. I can say that x is equals to minus 3. And similarly, I can say that x minus 1 is equals to 0, or I can say that x is equals to plus 1. So this two values gives me the cutoff in the horizontal line for the sign diagram. So next, what I will be doing is that I will be making a straight line, and this straight x-axis will have two cutoffs, that is minus 3 and plus 1. Now let me try to figure out the value it will assume, this function will assume when x is less than minus 3. So I can simply take, let's say, minus 5. So if I take minus 5, x is equals to minus 5 in this equation. So I will be getting minus 5 whole raised to the power 2 plus 2 times minus 5 minus 3. That gives me 25 minus 10 minus 3. That gives me a positive number. So I can conclude that whenever the value of x is less than minus 3, the function is going to give me a positive value. Similarly, let me try between minus 3 and 1. So the convenient number between minus 3 and 1 is 0. So if I take the value of x is equals to 0, I will be getting 0 whole raised to the power 2 plus 2 times 0 minus 3, which is minus 3, which is less than 0, which is a negative number. So I can simply write a negative sign over here. So when the value of x is between minus 3 and 1, the function will take a value of negative. And finally, when the function is more than 1, let me take x is equals to 2 here. That's 2 whole raised to the power 2 plus 2 times 2 minus 3. So clearly this is a positive number. So I can write a positive sign over there. So that was our question number one, where we figured out the sign diagram without using any calculator. Let us do a second question. So question number two, I have been given minus 4 times x minus 3 whole raised to the power 2. Since I have not been given any right hand side, I can simply equate this equation to 0. So from here, I can see that the possible cutoffs can be x is equals to 3. I hope you are clear with how I got x is equals to 3. So now next, let me draw a horizontal straight line. And this horizontal straight line will have a cutoff at 3. Okay. So if I take a value less than 3, let me take 0. So if I take a value less than 3, I can clearly see that this entire function will become negative. Okay, so a value less than 3, let me take x is equals to 0. So it will become minus 4 multiplied by minus 3 whole raised to the power 2, which is a negative number. And if I try to take a value more than 3, then still I will be getting a negative number. So that is how I tried to figure out the sign diagram without using calculator. So I hope the sign diagram and the quadratic inequalities are very much clear to you. Next, we are going to talk about how to solve quadratic inequalities. So for that, let me start with two questions. You can always write this equation in the form of 3x squared plus 5x minus 2 is greater than equals to 2. Now remember one thing, this entire thing, the entire left hand side is nothing but y. So we want the possible values of x so that the y will always be positive. So what we need to do next, we need to make a sign diagram. But before making the sign diagram, we need to have a clarity about the cutoffs. So this equation 3x squared plus 5x minus 2 greater than equals to 0 can be written in the form of 3x minus 1 times x plus 2 is greater than equals to 0. So from here, we get two different cutoffs. One cutoff is positive 1 by 3 and the other cutoff is minus 2. So let me make a horizontal x-axis. And in this horizontal x-axis, I have a cutoff of minus 2 and I have a cutoff of 1 by 3. And we can see that if I take a value of less than minus 2, then I will be getting a positive number. If I take a value of x between minus 2 and 1 by 3, I will be getting a negative value of y. And finally, if I take a value of more than 1 by 3, I will be getting a positive number. So we wanted to find out the possible values of x for which the function will take a value of more than or equals to 0. That means a positive value. So the possible values of x can be x less than equals to minus 2 and x more than equals to 1 by 3. So that's the answer for question number 1. Now let's move on to do question number 2. So for question number 2, I have been given x square plus 9 is less than 6x. So this entire thing can be rearranged and be written as x square minus 6x plus 9 is less than 0. Again, this thing can further be written as x minus 3 whole raised to the power 2, x minus 3 whole raised to the power 2 is less than 0. So I got my cutoff, and the cutoff is positive of 3. So this is the horizontal x-axis for the sign diagram, and the cutoff is a number 3. So if I take a value of x less than 3, let me take 0. So it will be giving me a positive number. If I take a value of x more than 3, I will still be getting a positive number. But I wanted to find out the possible values of x for which the function will take a negative value. So clearly, I'm not getting a negative value anywhere. So what I can say is that this inequality is not true for any real x. So my conclusion is this inequality is not true for any real x. So that was question number 2. I hope it was clear. Now let's move on and discuss question number 3. For our question number 3, we have example number 23 from our book. So I have been given a very strange looking quadratic function that contains x, y, and k. And I have been asked that what value should k take so that this parabola will cut the x-axis twice, or it will cut it once, or it will miss the x-axis. So let me write down the equation first. So it is k x square plus k plus 3 times x minus 1. I can clearly see that the value of A is equals to K, the value of B is equals to K plus 3, and the value of C is equals to minus 1. So since I am dealing with a case where I want to know if the uh, parabola will cut the x-axis twice or once, or maybe it misses it, so I know I should be using the concept of determinant over here. So the concept of determinant suggests me that determinant should be equals to b square minus 4ac. So this entire thing can be written as k plus 3 whole raised to the power 2 minus 4 times a times c. So this thing can again be rearranged to k square plus 6k plus 9 plus 4k, which can be written as k square plus 10k plus 9, and which can finally be written as k plus 9 times k plus 1. So this is the value of determinant. If I want the function to cut the x-axis twice, then I should know that the determinant should be greater than 0. So let me write it here. So if I want the function to cut the x-axis twice, the value of determinant should be more than 0. If I want the determinant to touch the x-axis, I want the value of determinant to be equals to 0. And if I want the function to miss the x-axis, then I want the value of determinant to be less than 0. So for this particular question, we are not going to solve the original quadratic function. Rather, we are going to solve this new quadratic function, the function of the determinant. Try and make the sign diagram, and let me try to picture out what exactly is happening. So clearly, if I make the horizontal k-axis, so I can see the cutoffs can be k equals to minus 9 and k equals to negative 1. If I take a value of less than minus 9, then I will be getting the value of determinant as positive. If I take the value between minus 9 and minus 1, I will be getting the value of determinant as negative. And finally, if I take any value of k more than minus 1, then the entire determinant will become positive. So for the first part, I wanted to get the possible values of k so that it cuts the x-axis twice. If I want to say that it cuts the x-axis twice, that means I want to say that the value of determinant should be more than 0. And this is possible only if k is less than minus 9 or k is more than minus 1. So let's move to the second part. The second part wanted me to find out the possible values of k where the determinant, where the function, original function will touch the x-axis once. So this is only possible if I take the value of k equals to -9 or k equals to -1. In that case, if I want the value of determinant to be equals to 0, then I want k equals to -9 or k equals to -1. In that case, the value of determinant will become 0. And finally, for the third part, if I want the value of determinant to be negative, why do I want it to be negative? Because the third part clearly states me that we do not want the parabola to intersect the x-axis. So if I want the value of determinant to be negative, then this happens when the value of k is between -9 and -1. So I can say that k has to be between -9 and -1. So that was example number 23, and that was the entire 5 video series on quadratic function. So I hope we are clear with quadratic functions. We are gonna see each other very soon, where I will be discussing chapter number 15, that is functions. So that is all for this video. Thank you so much, guys. Have a great day.